everyone and good day. We are Group 2 and we would like to discuss the topic of energy and followed by topic of heat.
Now, we take a look at the definition of energy. What is energy? Energy is the ability to work or produce change, such as capacity to move an object of a given mass by the application of force. Energy can exist in such various forms, such as kinetic energy, electrical energy, potential energy, thermal energy, and wind energy.
Throughout history, humans have relied on various forms of energy. In 1800, Thomas Young first introduced the word energy to the field of physics. 1850, James Prescott Joule published article on the mechanical equivalent. In 19th century, James Prescott Joule demonstrated the mechanical equivalent of heat, showing that energy could be converted between heat and work but was never created or destroyed. On the left, we have early image of oil drilling, symbolized the dawn of petroleum as a dominant energy source. To the right, we see a modern nuclear reactor representing the technology advancement in energy production.
Next, I will talk about theories in energy, which is law of conservation of energy. Total energy of an isolated system always remain constant. It also states that energy can neither be created nor destroyed, only converted from one form of energy to another. Next, I will talk about equations in energy, which is kinetic energy. It can be expressed as EK equal to 1 over 2 mu squared, which is m in mass and u in meter per second. Next is potential energy. It can be expressed as AP equal to mzg, which is m, mass, is in kilogram, and z, elevation in meter, and the acceleration of gravity in meter per second. The third equation is change in internal energy, which can be expressed as delta U equal to Q plus W, where U is the change in internal energy of a system during a process, Q is the heat, and W is the mechanical work. Last but not least is the total energy equation, which is E equal to U plus KE plus PE, where it totals up all of the energy in the system.
So this is our example on the energy topic. Next is solution that we calculate manually and the solution using MATLAB.
Moving on, we take a look at the definition of heat. What is heat? Heat is a form of energy that flows between objects due to a difference in their temperatures. When two objects at a different temperatures come into contact, energy in the form of heat moves to the hotter object to the cooler one until thermal equilibrium, which is equal temperature, is reached between these two objects.
Next is history of heat. In 18th century, Joseph Black discovered the eye absorbs heat without changing the temperature when melting. And then he involved the theory of latent heat and also showed the different substances have different specific heat. Sir Benjamin Thompson and Carl Rumford demonstrate a corner manufacture through a friction used possible to convert work to heat. Then in 19th century, Joule and Mayer demonstrate the heat and work were interchangeable and lead to principle of the conservation of energy by Hermann Holmby. Heat generally defined as a type of energy transferred due to the temperature difference and generated by friction.
Next, I will talk about theories in heat, which is caloric theory. It states that heat is supposed to be an indestructible imaginary fluid called the caloric, which flows from a body at higher temperature to a body at lower temperature. There are three mechanisms of heat transfer, which is conduction, convection, and radiation. I will talk about heat equation, which is first is Fourier's law, which is conduction. It can be expressed as Q equal to negative K gradient T, where T is the temperature gradient, K is the conductivity of the materials, and Q is the heat flux density vector. Second is Newton's law of cooling, which is convection that can be expressed as T at given time is equal to T surrounding plus T naught minus T surrounding exponential to the power of negative KT. The third equation is Stefan-Boltzmann's law, which is radiation, that its mathematical form is E equal to sigma T to the power of 4, where E is the radiant heat energy, T is the absolute temperature, and sigma is the constant of proportionality called Stefan-Boltzmann constants. Last but not least is the heat transfer, where Q is equal to mc delta T, where m is the mass, C is the specific heat capacity, and delta T is change in temperature.
So this is our example on the heat topic. And next is our solution that we calculate manually and the solution using MATLAB.